So here we have a set of parametric equations that define some planar curve, and we're going to sketch the graph. So to sketch a graph of a curve given parametric equations, just really start thinking about values for t. Um, I'm going to start at t, say, equals -3, and just go up from there until I can see some kind of pattern. Hopefully, I'll see a pattern. When t equals 3, x would be 1 minus 1/3, according to this equation, so about 2/3. And y would be -3 minus 1 is -4. So I'm at around x equals 2/3, y equals -4. And now I'll go to t equals -2. X would be 1 minus 1/2, so 1/2. Y would be -3. So 1/2 comma -3. T equals -1. Y would be 1 minus 1, which is 0. X would be 0. Y would be -1 minus 1, which is -2. So you can see what's happening here. This graph looks like it's being formed like this. So I'll try t equals, well, I can't make t equal 0 because that's undefined over here. So let's try just t equals, um, let's try -1/2. If t is -1/2, x would be 1 minus 2, which is a -1, and y would be -3/2. So it looks like this graph is forming like this. And that's my orientation. You show the arrows. That tells you exactly which direction it's going in. Now, I know 1 was an issue. T equals 0 was an issue. So I'm going to jump past that and see what happens at t equals 1. When t equals 1, x would be 1, 2, 1 plus 1, and y would be 0. So 2 comma 0. Is that part of the graph? Let's go t equals 2, 1.5, comma 1. So I'm here. Let's try 3, 1 and 1/3, comma 2. So 1 and 1/3, comma 2. So you can see it's kind of forming like this. But remember, it's going in this direction. So that's what our graph is looking like. Looks like we probably have an asymptote here, but that's how you do it. Now, the other way to do it is to eliminate the parameter and do it so it's in rectangular coordinates. So take it out of parametric form. So the way to do that is to solve for the parameter. T is called the parameter. I'm going to solve for this t because it's easy. T equals y plus 1. You can plug that in for the t in the x, and then you automatically have something in terms of x and y, something we're a little bit more used to. So now we could just plug in values of x and y, and we should get the same points. Um, Now this is not the, let's try to solve this for y. I'm going to flip both sides here. Y plus 1 equals 1 over x minus 1. So that tells me y equals 1 over x minus 1 minus 1. So let's just quickly graph that on our graphing calculators to see what it looks like. One over x minus 1 minus 1. So I already have it in parametric form. I'll show you that in a second. So I'm going to graph 1 over x plus 1 and then, 1 over x minus 1 minus 1. So this is taking a little bit longer than I thought. Sorry about that, but that's how she goes. This graph looks like so. Now that looks pretty familiar. That looks like the graph we just graphed. So that's a great way to check your work. The only thing is, if you do it in rectangular coordinates, you don't have the direction. So you're still going to have to figure out what direction, the orientation, the arrow points. But this is a good representation. Now, you can also change your calculator to parametric mode like I had before. So you can go to mode and change it to parametric. And then your y equals will give you an x and a y. And you just type those in. X was 1 plus 1 over t. 1 plus 1 over t. And y is, and y was t minus 1. And then when you graph that, that should also look like the graph we just had. Kind of messed up here because there was an undefined point. So I'm going to change my t. Let's go from negative 4 to 4. Just see what it looks like. All right, so that looks like what our graph was looking like. So that's the lowdown on parametric graphs. You can also do this in Desmos quickly. I pre-did it here. And then you can change, you can see how it's formed. Just like we formed it. It starts down here and then goes all the way to the left and then restarts on the right-hand side, you can see, and then goes up to the asymptote. So that's the lowdown on parametric equations. Mess around with them. They're fun. And I'll see you next time as soon as I can figure out how to turn this thing off. I lost it. So as I think I just got it.